The electrolysis of water is a very reliable way to obtain small quantities of hydrogen and oxygen gas very easily and inexpensively. It involves only a few main components: 1. A DC power supply greater than 1.23 volts, 2. A cathode and anode, and 3. A reciprocal for the gases being produced. The reaction is a simple one. Essentially what happens is at the negatively charged cathode, a reduction reaction takes place, with electrons from the cathode being given to the hydrogen cations to form hydrogen gas. At the positively charged anode, an oxidation reaction occurs, generating oxygen gas and giving electrodes to the anode to complete the circuit. Since these reactions take place at the cathode and anode respectively, the hydrogen and oxygen gas can be collected separately, although for my purposes this didn't seem necessary. So with a bit of research and an insatiable desire for explosions, I set to work creating my own hydrogen generator. To start off, I found an empty plastic container that I felt would be about the right size for my project. Next, I had to find 2 pieces of metal to act as the cathode and anode. These needed to be fairly thick as the reaction seems to corrode the metal extremely quickly. After looking around for almost an hour, I settled on 2 bolts, but in the back of my mind I was really hoping for something a little bigger. Anyway, I got to work putting together the main components of the generator and soldering connections to the power source, a butcher micro USB charger, to the cathode and anode. I wanted to be able to move my whole setup around easily, so instead of soldering the leads straight to the cathode and anode, I used a few XT60 plugs I had lying around to drastically decrease the cord length and make it a lot more manageable in general. My original plan was to attach a cathode and anode to the lid of my container, and then have a balloon towards the edge of it. I was hoping that this would allow me to quickly and easily collect whatever gases had been produced without much loss. I figured that it was a risk as there might not be enough pressure from the gases to actually inflate the balloon, but in the end I wasn't able to find any, nor could I go out to buy any due to the lockdown. So I settled on a different solution, which ended up working. The second solution was to have the cathode and anode at the bottom of the container and have a jar filled with water sitting on top of them. As the volume of the gas increased, the pressure would push the water out of the jar until eventually the jar would be void of water and full of hydrogen and oxygen gas. Once I completed it, I turned it on and carefully monitored it for an increase in gas. I left it for about an hour, and when I came back there was hardly any change, so I left it for another 2 hours expecting the same result. But this time when I got back it had completely filled with gas. I think what happened there is that there was a lot of suction pressing and sealing the jar to the bottom of the container, and at some point the pressure overpowered the seal and equilibrium was restored, releasing the water. Once the jar had filled, I took a large syringe and carefully tried to suck up all of the gas while trying not to disturb it too much, mixing it with the gas in our atmosphere and contaminating the sample. Now with my syringe full of hydrogen and oxygen gas, I went outside with it and tried inserting it into an empty pop can, but unfortunately it was extremely windy that day and I think a lot of the gas escaped through the turbulence, which resulted in a rather underwhelming explosion.
Science experiment. That was it. It worked.
I was really hoping for a more impressive explosion, so I went for round 2. I made sure to check my experiment often, as last time the water overflowed and left a bit of a mess. This time I tried blowing bubbles with the gas into some soapy water, but it had about the same reaction, so I did a little digging and found that the ideal ratio for hydrogen to oxygen is 4:1, which meant I needed a way to separate the hydrogen and oxygen to combine them into the ideal ratio later, but unfortunately I ran out of time. I may tinker with it a bit more in the future and try to hit the ideal ratio, but for now this will have to do.